Microsoft Security Copilot, what always-on AI incident response looks like. Explain what Microsoft's dynamic threat detection agent shows about real enterprise AI agents, how always-on investigation changes security workflows, and what builders should copy before claiming they have an agentic workflow. If you want a better definition of a real AI agent, this paper is a useful place to start. Microsoft researchers describe a dynamic threat detection agent that continuously investigates incidents across Defender, gathers evidence, tests hypotheses, and generates explainable detections when the original alert story has gaps. That is different from a one-shot chatbot answer. It is an ongoing workflow that has to survive noisy data, shifting context, and operational limits. The skeptical question is whether this is really an agent or just a dressed-up rules engine. The paper's answer is more useful than the label. DTDA builds a unified activity timeline from alerts, events, user and entity behavior analytics, and threat intelligence. Then it runs a planner-executor loop that proposes attack hypotheses, gathers supporting and refuting evidence, and only then generates a contextual alert with severity, MITRE mappings, remediation guidance, implicated entities, and a natural language description. In plain English, it does not just summarize. It investigates. The most important part of the paper may be the least glamorous part. The system uses versioned prompt contracts, schema validation, grounding requirements, bounded retries, and fail-closed suppression. That is the workflow lesson. Real AI operations are not magical because the model is stronger. They become usable because the workflow is constrained. The agent has to prove what it saw, stay inside a defined structure, and stop when confidence or process rules break down. That is how you get speed without silent errors. The paper gives viewers something rare in the AI agent discussion: operating numbers. It reports 80.1% precision from customer feedback in a 120-day online evaluation, novel alerts for about 15% of investigated incidents, a median end-to-end investigation time of 28 minutes, a median token cost of $2.04, and a job-level failure rate of 0.38%. The skeptical analyst asks, are those numbers perfect? No. But they are concrete enough to evaluate, compare, and learn from. That is much more useful than vague claims that an agent is transformational. There are limits. This workflow lives inside Microsoft's security ecosystem, which gives it rich telemetry and controlled execution surfaces. Not every team has that advantage. Security also has clearer feedback loops than many other knowledge work tasks. So do not overgeneralize and assume your sales, finance, or content agent can copy this architecture without adaptation. The transferable lesson is not the exact product. It is the design pattern, grounded evidence, bounded loops, explicit outputs, and measurable operations. Here is the Monday morning takeaway. If you are building any AI workflow that matters, copy the boring parts first. Require source grounding before action. Validate output structure before downstream steps run. Cap retries so the system cannot spiral. Record which evidence supported the recommendation. Decide where a human approves, where the agent only drafts, and what rollback looks like. Those controls are not anti-agent. They are what make an agent deployable. Not included. My judgment is that this paper shows what a real AI workflow looks like when the hype is stripped away. It is not raw autonomy. It is bounded autonomy with evidence, structure, and measurable costs. That is the model builders should study. When you design your next AI workflow, which guardrail matters most: evidence, approval, retry bounds, or rollback? Create a polished whiteboard explainer with a calm lead narrator and skeptical analyst handoff moments. Use SOC timeline boards, alert queues, evidence cards, planner executor diagrams, metric panels, and operator checklists. Keep visuals changing every 3 to 5 seconds. Show the architecture simply and clearly. Avoid fake malware footage, fake hacked company scenes, or sensational cyber imagery. Keep the tone grounded, precise, and practical for operators. 1 May 20, 2026, initial paper submission date. 2 May 22, 2026, revised paper version date. 3 120 days, online evaluation window. 480.1%, precision from customer feedback. 515%, novel alerts share of investigated incidents. 60.78, offline F1 score using GPT 5.4. 7 plus 0.12, F1 improvement over GPT 4.1. 8 plus 0.26, F1 improvement over baseline. 9:28 minutes, median end-to-end investigation time. $10.04, median token cost per investigation. 0.38%, job level failure rate. 12 tens of thousands, defender customers mentioned in the paper. 1350 of 60, total topic score. 1410 of 10, business relevance score. 15.9 of 10, visual explainability score. 1 one-page summary 2. Links mentioned 3. Key terms explained 4. Practical examples 5. Watch list and risks educational content only. Not financial advice. Hashtag Microsoft, hashtag Security Copilot, hashtag AI agents, hashtag Cybersecurity, hashtag AI workflow.